We're multiplying by the least common denominator. I'm going to look here. So between 2 and 4, what is the smallest number they both divide evenly into? 4. The smallest number they both divide evenly into. Okay? 4 cannot divide into 2 evenly. Does that make sense? But 2 can divide into 4, and 4 can divide it into 4. So you're going to multiply both sides by the LCD. 4 times a half is 2. 4 times 1/4, about $4 divided by 4 people. What am I going to get? Everybody gets $1. And 10 times 4 is 40. Okay? So, that's step 1. I'm going to do the same thing with 1/8. Well, 1/8 is easy. What is the LCD? 8. So I'm going to multiply by 8, and I'm going to be left with 1x minus 1y equals, what's 19 times 8? You will look calculate. 19 times 8.
19?
Mm-hmm. 178?
Maybe. I don't know, Miss.
I don't know.
No.
I just can't,
That's not right.
I don't think it's right.
That's all right. 152.
God dang.
All right. So then now we're here. So this is called, when this happens, when you have small numbers, it's called elimination. Okay? Systems by elimination. So systems by elimination means I'm going to multiply one of these numbers by something so that I can cancel out the other. Okay? Notice here how I have 2 negative 1s, right, for y values. So for these values right here, if I can make one of them positive, then I can cancel the other out. Does that make sense? So I'm going to multiply everything down here by negative 1. What that's going to do is turn this into negative x plus 1y equals negative 152. The reason why you do that is because you want to be able to eliminate one of the variables. Okay? So now when I combine these two, these are going to cancel out, and I'm left with, what's 2x minus x? X. What is 40 minus 152? Negative. So now I know the value of my x value. And once I know the value of my x value, I don't have to go any further. The value of my x is negative 112. Okay? So that's completely by hand. Alright?
I remember doing this.
Okay? It's very vague, I know, but that's by hand. I'm going to erase, and then we can talk about doing it by calculus. Alright, so eraser. So we now know how to do it that way. The other way is by calculator. And by calculator, there's you would have learned with the 84s how to do the matrix method. That's actually this year. But we're going to talk about getting y by itself. So when you get y by itself, that's moving your x term, dividing by your coefficient. Do y'all remember getting y by itself? So having to get y by itself. So if I had 1/2 x minus 1/4 y equals 10, the first thing I'm going to do is subtract the half x, right? So I subtract 1/2 x, and I'm left with negative 1/4 y equals negative 1/2 x plus 10. Right? Y'all remember doing that? And that would divide by negative 1/4. But when you divide a fraction, that means you're multiplying by its reciprocal. Does that ring a bell? You flip the fraction. Keep, change, flip. So I'm actually multiplying by negative 4. And that cancels this out. So y equals, I'm just letting y'all know that it's recording, so it's going to be recording your whole conversation. Just FYI. So whatever you're saying, it's been recorded. 2x minus 40. Okay, so that's our first y. So we have 2x minus 40. You're going to repeat that process here. So we're going to do it again. So this time we have 1/8 x minus 1/8 y equals 19. So I'm going to subtract 1/8 x. So I'm left with negative 1/8 y equals negative 1/8 x plus 19. Notice how because 19 is positive, it's being added, not subtracted. Does that make sense? Okay, again, how do you get rid of a fraction? You multiply by its reciprocal. Okay, so I'm going to multiply both sides by negative 8. So my equation is y equals negative, a negative times a negative is a positive, and 8 divided by 8 is 1. And 19 times negative 8, we already said was negative 152. So you're going to take these two equations and graph them and see where they intersect. Okay, so we're going to graph that. So we're going to graph. I got to unfreeze the screen so that. Come on. Okay. So we're graphing. We're going to go to y equals. I'm going to reset my calculator. Second plus 712. And what was our first equation? 2x plus 40. And our second equation was? It was x minus 152. So now that you have that in there, you want to graph. And what's going to happen is that if you look at our numbers, our graph isn't going to show us anything because our window's not right. So we're going to have to zoom out a little bit. So I'm going to press 3. I'm going to zoom out. I see 1, but I don't see the other. So I'm going to zoom out some more. Yep, zoom on out. You have to be able to see both lines. And like, oh man, I'm going the wrong way. So that didn't work. I get tired of zooming, so I typically end up going over to my, what's this thing called? My windows and changing my windows so that I can see everything. So I'm like, all right, we're going to make you negative 300. We're going to make you, I don't know, 200. We're going to count by 50s. It's literally a playing with the settings and being comfortable moving the settings. And then I'm going to hit graph and let's see, will it show me something? Oh, not quite. I do not see my intersection. So zoom stat is only if you have data. We don't have data in, so it's not being able to do anything, but you can try zoom fit. So there is zoom fit, and it's like, I want the calculator to take a stab at figuring out the best window for me. So when I press zoom fit, it's like, this is all I got.
I think it's negative 192.
Okay, so I'm going to zoom out even more. This time I'm going to zoom. I can see where the intersection's happening. I can zoom to the left and down a little bit, right? So notice how I moved my cursor to tell it where I want it to go. I want you to zoom over here and show me some action. It worked. So now you can see the point of intersection. So on here is your point of intersection. And if you want the calculator to do the work for you, personally, I think it's faster by hand. But if you want the calculator to do the work, it's second, trace, and you see where it says intersect. And you're going to press 5 and enter 3 times. So 5, and it's like, you want this curve? Yeah. You want this curve? Yeah. You want me to guess? Yeah. And then it'll guess for you. I either did something wrong. I typed something in wrong. What was our values? It was minus 40, wasn't it? And you were just going to let me keep writing that. I didn't hear you. There we go. Minus, I was like, that is not what I got earlier. Let's try that again. So 5, and again, how many times do I press enter? 3 times. 1, 2, 3. Oh my gosh, it's negative 112. Okay. So we talked about how to do it hand and graphically. We will be diving deeper into systems here at some point in our class, but we're going to learn about systems, solving them more algebraically, and hopefully, again, working on filling some of those algebra gaps, right?
Are these notes the rate of change refresh or the constant rate of change notes?
Rate of change refresh. The constant rate of change notes were just ones you could write in your notebook. All right, that's all I got.